Hey everybody. Okay, what I want to do in this video is I just want to take you through the linear functions recap worksheet, right? Just to give you answer any questions that you may have, right? If we go through the do now, they're giving you your slope and your y-intercept. I'm hoping that that is a pretty basic concept that you are remembering that in your y equals mx plus b formula, m is your slope and b is your y-intercept. So you would simply write your equation by writing y equals 3x minus 6, because your slope is always your coefficient to your x and your y-intercept is always your constant. Okay? All right. This next section was going over a function versus not a function. In order to be a function, each x value has to have one and only one y value. So if you look at the mapping type questions, to be a function, each x has to have one arrow coming off of it. So this one is not a function. And remember, the first box is always your x and the second is your y. This is your input, this is your output. If you come down to question number 4, since each of these inputs or x values has only one arrow coming off of it, it is a function. For graphs, we used what was called the vertical line test in order to be a function. So I need to be able to draw any vertical line I want and only hit a part of the graph in one and only one spot, which will happen here. This is a function. It passes the vertical line test. This one is not, because when I draw a line down here, I'm hitting 2 spots. That means that the x value of 1 maps to the y value of 2 and the y value of 3. That's why we have the vertical line test. It will show us when an x value has more than one y value. But this one is not a function. It fails the vertical line test. For a table or a list of ordered pairs, what you're really doing is you're looking for a repeated x value that has a different y value. So this is an example of what is not a function, because I have an x value that maps to 4, 1, 4, and 1, 7. Again, you're only looking from your x's to your y's in order to figure out if you have a function. Same with a list of ordered pairs. My x values are 0, 1, 2, and 3. So I do not have a repeated x value. Therefore, this is a function. And that's just a reminder of function versus not a function. This next section, we were doing linear versus non-linear. So the assumption is that these are all functions. And as I quickly scan through, they are all functions. The question is, are they linear functions or are they non-linear functions? Okay, when you're looking at a graph, it's really easy to tell. Straight lines are linear functions and non-straight lines are non-linear. To be a linear function, you must graph an absolutely straight line. In terms of equations, in order to be linear, you have to be in y equals mx plus b form, which this equation is in y equals mx plus b form. This one has this x squared. That's a quadratic. That's non-linear. That's going to graph a parabola. This is linear because it's in y equals mx plus b form. Okay, the table part can be a little bit tricky because, again, for this one, what you want to make sure of is to be a linear function, you have a constant rate of change. And now that phrase, rate of change, that really is your slope. Remember, slope only associates itself with linear functions, and it's that change in y over that change in x. And as long as that change in y over change in x is constant, then you have a linear function. So if you look at this table, I was, what did I do? I increased by 4 as I increased by 1. And I increased by 4 as I increased by 1. I increased by 4 as I increased by 1. So we would say this is a linear function because it has a constant rate of change. I just want to point one more thing out to you. If I had a bigger jump and I said, oh, but now I'm increasing by 8 as I increase by 4, that is still the same constant rate of change, because remember, you're doing y over x, because 4 over 1 is equivalent to 8 over this should be 0 to 2 is an increase in 2. I apologize. So 4 over 1 is equivalent to 8 over 2. They all simplify down to a slope of 4. So that constant rate of change exists. It has to just be that those change in y over change in x's continuously come down to be equivalent fractions. as opposed to this guy where I'm increasing by 1 as I increase by 1. Now I'm increasing by 4 as I increase by 1. Now I'm increasing by 18 as I increase by 1. That's nonlinear. I don't have a constant rate of change. Okay. This section over here is evaluating your function, really your function notation. This f of x and f of 6, and this is where f of x is equal to -5. You just want to start to understand the difference between the two. So I'm going to pair these off. If you look at this one, I'm establishing f of x is equal to -2x plus 2. F of 6 is asking me to take 6 and plug it in for the x value. So therefore, f of 6 is going to equal -2 times 6 plus 2. You're going to get -12 plus 2, and you're going to get that f of 6 is equal to -10. That means that when x was 6, y was -10. All right, notice I'm asking you to find f of 6. Now, if you take that this way to number 17 is written a little different. I'm not giving you h of 1. I'm telling you that h of x is equal to 1. So the way that's different is if you take this function rule, this 1 isn't being plugged in for x. Instead, it's being plugged in for the whole entire h of x, which really just means it's your y value. So I would rewrite this function as 1 equals -3x minus 2, and now you're solving for your you're solving for your x value. So 3 is equal to -3x. And when you divide by -3, you would get x is equal to -1. So when y was 1, x was -1. Okay, so x turned out to be -1 when y was 1. And remember, y is the same as h of x. It's just another fancy way of writing y is writing it as h of x. So when h of x was 1, we solved and got an x value of -1. Just kind of making those two connections together. Okay, you can practice that with 14 and 18, very similar. 15 and 16 are a little different in the sense that you're looking at a graph. And remember, if I say, hey, what is f of -3? That means I want to know what is your y value when x is -3. So I'm going to come to -3 and I'm going to go down. And because of this coordinate, -3, -7, I can see that the y value is -7, which is the answer to this question. Over here, remember, because of the way it's written, f of x is equal to 5, that -5, that makes your -5 your y value. So I'm going to go where my y value is -5, and I'm going to look 1, 2, 3, 4, 5. I'm going to look for the point, which this point is the point 4, -5. So I want to find my x value where f of x is equal to -5. That's the same as me saying find x when y is -5. So the x value would be 4. Okay. All right. This next section, I did mark it up a little bit ahead of time to make it a little easier. I'm only going to do a few of them to kind of leave you some to practice with. But remember, your domain are your x values and your range are your y values. And it really is about boxing in your graphs. So if you look at this first one, my domain is my left to my right boundary. So the part of the x-axis that I am using is from -5 to 0. So my lower or my left boundary is -5 and my right boundary is 0. Because of this open circle, it is exclusive on the 5, and because of this closed circle, it is inclusive on the 0. That's as I'm looking at the graph from left to right. That's what your domain does. It makes you look at your graph from left to right. Your range makes you look at your graph from bottom to top. So my bottom boundary is 4, whereas my top boundary is 5. And I apologize, this 4 is really a -4. So my bottom boundary is at -4. It's a closed circle, so it is inclusive. And then my top boundary is at 5 with that open circle, so it is exclusive. All right. Don't be tricked by this one that has this swirl. My left to right boundary is -5 up to the 3. And it includes the 3 because there is a portion of the graph that's touching on the 3. So therefore, my domain would be -5 inclusive, right? -5 up to 3 inclusive. My range, bottom to top, I'm going from -3 inclusive up to +3 inclusive. And those two are inclusive because of those closed circles. Right? If you have an arrow, it's going to create those infinities. So my domain, my left to right boundary is going to be, my left boundary is -4, exclusive because of that open circle, and it goes to infinity. There is no right boundary because of this arrow. So it goes out to infinity. Infinities always get exclusive. Your range, there is no bottom boundary because of the arrow. So it's -infinity exclusive, but the top boundary is +3. And that's exclusive as well because of the open circle. And then if I happen to give you one of these dotted graphs, then you're really just, you could just list the coordinates. And then for the domain, you're just giving me your x values, which in this case is going to be -3, -1, 0, 1, 2, and 4. I'm just going to grab that 4 and use it. Don't repeat a value if a value is repeated. You do not need to. And your y value, that's your domain. Excuse me, your y value is your range. So now I'm going to go through and my y values are -2, -1, 1, and 3. Okay. And again, notice I didn't repeat that 3, even though it showed up 3 times. I only needed one of them. So again, your domain is your x values, your range is your y values. Okay. This reminded you how to use your slope formula, y equals mx plus b. If I give you your slope, that becomes the coefficient to the x, so y equals 5x, and your y-intercept plus 3. Don't forget your y equals, the biggest mistake kids will make. So one more time, if your slope is 0, y equals 0x, y-intercept is -4 minus 4. Now I wouldn't leave this like this. Since 0 times x is 0, I would just write y equals -4. You can clean up these equations. I'm going to leave you 27 to practice on your own. Okay. If I give you a table, some of the things you wanted to remember is that when you are using your y equals mx plus b form, m is your slope, right? Change in y over change in x. So from a table, the change in y, in this case, I was adding 8 for my y value over the change in x. I was adding 1. So +1. So my slope is 8. That's how you find your slope, change in y over change in x. And your y-intercept is where your x value is 0. So since x is 0 here, that makes your y-intercept 6. So your b value is 6. So the equation for this is going to be y equals 8x plus 6. All right? And then again, you can kind of practice with your other equations. Change in y or change in x, and then look for that y-intercept in your table. Practice the others. And then you can check your work in Google Classroom. All right, similarly, when you are asked for the equation of a line from a graph, now notice every time I ask you for the equation of a line, what you basically need to do is find your slope and you need to find your y-intercept. For your tables, I pointed out to you that your y-intercept was where your x value was 0. From a graph, your y-intercept is simply where the graph crosses the y-axis. So in this case, the b value is just going to be -8. I can see it. It's where it crosses the y-axis. That's your y-intercept. Now, your slope is a little bit harder. I'm going to use this direction. I'm going to look at my graph from left to right, and I am noticing these nice slope dots pre-printed on your graph. It appears that I'm going down 5 and to the right one every time, down 5 and to the right one every time, down 5 and to the right one every time. And in order to say down 5, that's a -5 on the top. Remember, the top number is always your up-down movement. And then I moved to the right, which is a +1. Your bottom number is always your left-to-right movement. So -5 over 1 is going to give you a slope of -5. So therefore, my equation is y equals negative 5x plus 8. All right. Some kids will see this as up 5 and to the left 1, up 5 and to the left 1. You're technically reading it backward, but up 5 is positive 5, and then when you're going to the left 1, it's negative 1. So you'll still get that same slope of negative 5. So it's okay to read it backward. You just can't make this fraction upside down. You can't put your left-right movement on the top and your up-down movement on the bottom. Always change in y over change in x. And your y-axis moves up and down. Your x-axis moves side to side. Right? And last but not least, this is reminding you how to graph, which again, M we said stood for the motion or the movement of the line, and your B is where you begin. It's your y-intercept. So if you look at this equation, which is nicely in y equals mx plus b form, I'm going to begin at the one on the y-axis. So here's my point at positive 1. And my slope is negative 3 over 2. Now, the negative sign is out in front. I choose to throw it to the top number. You can only use that negative sign once, and it's telling you to go down 3 and to the right 2. So from my point, my y-intercept where I began, I'm going to move down 3 and to the right 2. And I'm going to keep going down 3 and to the right 2. Notice I am graphing a downhill line. I'm going to reverse it, up 3, left 2. I'm graphing a downhill line, which makes sense because this equation had a negative slope, as opposed to this equation has a positive slope. I can write 2 as a fraction by putting it 2 over 1. That tells me to go up 2 to the right 1, but I'm going to begin at negative 4 on your y-axis. So 1, 2, 3, 4. Here I am, negative 4. Now I'm going to go up 2 to the right 1. Notice this is graphing an uphill line, and that's because it had a positive slope. Okay, I hope this was helpful in just reviewing all of the concepts that we needed to recap for what we learned before the break. All right, go through, finish some of the questions I skipped, and check your work. Ask your questions.